All right, folks, welcome back to another OpenShift Commons briefing. We're streaming live on YouTube, Facebook, and Twitch. And today we have Juana Nakfour from the OpenDataHub team, who's going to talk to us about OpenDataHub, Kubeflow, and running it all on OpenShift, which is a flavor of Kubernetes. And we're really excited. The Kubeflow folks have done a lot of great work making this all possible. So there's a couple of them that are on the call as well. So we're going to let Juana introduce herself, give us a talk for a little while here about the topic, how everything's going, give us an update on OpenDataHub and where it's going and what's going on under the hood. And then we'll have live Q&A and a conversation afterwards. So Juana, take it away, introduce yourself, and if you have questions, pop them in the chat wherever you are.
Thanks, Diane, and thanks for inviting me also here to do this presentation. My name is Juana Nakfour. I am part of the CTO AI Center of Excellence and specifically working on the OpenDataHub project. So in this presentation, I'll go over an introduction on what OpenDataHub is. I'm sure most of you have already heard of OpenDataHub. I'll dig a little bit into the history of OpenDataHub, how it started. I'll add more information on where we are today, an update on the project, a little introduction on Kubeflow and how we integrated with Kubeflow, where OpenDataHub is used today, and then at the end, I'll have a kind of a little introduction demo, and it will be focused more on Kubeflow and specifically on pipelines and notebooks. So what is OpenDataHub and how did OpenDataHub start? So originally, OpenDataHub started as an internal project inside of Red Hat. So we were basically asked to provide storage for different data science, machine learning analysis for the data scientists. And we learned a lot from just providing the data platform for them, and hence the name DataHub. But the project has evolved a lot, and I would say it is more of a machine learning platform than actually a data hub, as the word says, as the name says. But by providing tools for data scientists, we learned about what data scientists expect from a platform. They are more UI driven. They want all their libraries and all their resources in one place to be maybe installed in one click. And then they don't like doing things on terminal. They don't want terminal commands or anything. They just want to install one click and have everything there for them, integrated, ready to develop their models, get their data, have access to their data, etc. So the more we learned, we figured, let's just build a project and make this project open source and get the community around it so we can make it more smart and more available for other data scientists and other teams. And that's basically the history of OpenDataHub. So as we go more into the challenges that data scientists in different teams face, while we talk to different teams of data scientists for like different users, most of them face pretty much the same set of challenges. I think the first and most difficult challenge is really sharing. Most data scientists work on notebooks, and how do they share this code? And usually their notebooks are big notebooks with a lot of testing in it, not just creating the model and validating the model, but a lot of things that they try, and then how do you share this information with other data scientists in the team? And not only sharing code, but how do you share resources, right? They have to have their models running in clusters, and clusters have limited resources. They have limited CPU, they have limited memory, etc. How do we make sure that not one data scientist is taking over this one GPU or two GPUs that we have and not letting go of it? And of course, at the end, moving from the development phase to production phase is also a big challenge, because it is the production phase really is not just a one-stop end phase. It is a constant monitoring phase where you're monitoring the model, you're monitoring the data that's coming in. Is it drifting? How do I retrain the model? When do I need to retrain the model? Or when do I need to send the model back to production? And that gets, of course, more difficult when you're actually putting that model in production in different areas or different clusters. And that's the case for what we see on production for AI on the edge. So here comes OpenDataHub, right? So what is OpenDataHub? For all information on OpenDataHub, please go to opendatahub.io. That is our main entry point to all information with regards to OpenDataHub. Today, we call it a meta project because it brings all these different open source tools together into an operator. And that's a community operator that can be installed today on OpenShift. So if you go to the OpenShift catalog and you search for OpenDataHub, which I'll show you right now in the demo, you'll see it there and you can install it, and it will download and install many tools for you. And these tools basically target each stage of the different phases of an end-to-end AI/ML model. So if we look at the picture here, starting at the data engineers, even though today we don't have a data storage, we are planning on putting a minimal storage in there. We had that before, but we pulled it out because support for it was not there anymore. We do have tools for data ingestion and transformation, and I'll talk about them in more depth here in a little bit. And then moving on to the data scientist, the data analysis part, model building, model training and validation and optimization. And then after we have the model, we're ready to put it in production. How do we serve the model? And of course, we're monitoring the model and constantly optimizing. And the optimization phase, maybe this picture is not very accurate, but really it should be, it should involve a data engineer and a data science and maybe the business intelligence people too, that all feedback back to see how we can optimize this model and keep keeping it fresh and keeping it updated. So we also built an ecosystem around OpenDataHub. And I say ecosystem because most of our users and customers always come to us and ask, I want to use OpenDataHub in production. What's supported and what's not supported? So just to stress, OpenDataHub is not a product. It is an open source project. But we built the ecosystem around it to provide support. For example, we integrate with most of the Red Hat products. We're running on OpenShift. We integrate with Ceph storage. We have use cases such as fraud detection, integrating with Decision Manager. We have documentation and actually code to integrate with Service Mesh. And we also integrate with Zscaler API management. We also have a team that does consulting engagement with customers, kind of to bring OpenDataHub, to make it easier to integrate with OpenDataHub. And then at the left side, and these are really important, we have certified partners. These are partners that come to us and they get certified over OpenShift. They use UBI images and they certify their operator, and we try to integrate them inside OpenDataHub. And the biggest example that we have today, which is the first, is Selden. Selden, the certified Selden, is part of OpenDataHub today, and you can install it today and get support from the Selden team. And we have other partners too that we try to integrate with. Maybe if they're not part of OpenDataHub, we try to develop use cases where we show users how they can put this all together. And of course, we try to always have use cases to make it easier for users to understand how to use OpenDataHub. We have use cases in different industries. I mentioned fraud detection. We're also working on other ones too. So that's it for the OpenDataHub ecosystem. This is just showing the relationship between the different open source projects that go into OpenDataHub. So we have kind of an upstream downstream relationship with these projects. We take from them, we make whatever we take working in OpenShift, and any changes that we have or any upgrades or additions, we pump up back to the communities. And the biggest one here that you see is Kubeflow, but we have other communities, for example, Jupyter, Selden, Spark, Grafana, Prometheus, Kafka, and Argo. And at the end, I mean, the goal is to put all these together, get them working on OpenShift, and then provide them as an operator hub in OpenShift, Red Hat OpenShift. All right, so a little bit here about our releases. We started releasing OpenDataHub earlier in, I think it was January 2019, when it was like 3 things. It was Jupyter Hub, it was Ceph Nano, and it was Spark. And then it grew, and we added more and more. We started as an Ansible operator, and we moved through the releases. The last one for the Ansible operator was OpenDataHub 0.5, and it had many tools. I will go through them here in a little bit. But then, and we tried, and we brought Kubeflow 0.7 and got it working on OpenShift, but that was not part of the operator. But to have a better alignment with Kubeflow, we kind of migrated our Ansible operator into Kubeflow KFCL operator. And then today, when you're trying to download, and I'll show you this in the demo, when you're trying to download OpenShift, OpenDataHub, you'll see that there are 2 channels. One is the legacy channel, which is the Ansible operator, and that has all the different components that we had originally. And one is the 0.6 beta channel, and that will have the OpenDataHub migrated components to the new manifest that we have with Kubeflow, and it will also install Kubeflow for you. And then I will show you this here in a little bit. So 0.6.1 is the biggest, it was the first migration for the release, and we had all the components migrated from Ansible to KFCTL manifests. And then this operator is Go based, and we had Kubeflow 0.7 integrated with this operator. And today we are working on 0.7, which will be released this week. I'm hoping end of this week. We're already done. We're just doing the last bits and pieces of it. And it will include CI and testing. We kind of, it will not include KF serving because we still have issues with it. And you'll see that when you're installing Kubeflow, some components are still blocked off or commented off because we have not gotten to them yet to get them to work on OpenShift. And I'll point them out here in the demo in a little bit. And then we also did some bug fixing in 0.7, a lot of testing. You'll see a lot of testing that we added. We're kind of building our CI/CD platform and little by little adding automated testing to most of the components. And down the line, end of August, we'll have 0.8. I want to just pinpoint one thing here that we're working on is mixing ODH and KF. I'm sure you're looking at it and you're wondering, what does mixing mean? Mixing is trying to, so the way, and I'll show you here in a little bit, the way you install the components, you can actually pick and choose which components you want. You just add them to the manifest or you take them out of the manifest. But we have OpenDataHub components and we have Kubeflow components. At the moment now, they cannot be mixed. Like you cannot have one manifest that has components from both. I think we might have add TF jobs here and PyTorch. But what we're working, and that's mostly the reason behind this is there is a static namespace somewhere down the line in files that specifically says has to be, let's say, for Kubeflow or OpenData. And we're trying to fix this so that we can mix and match. So you can have, for example, Prometheus from OpenDataHub, and let's say Jupyter server from Kubeflow, and that's what the mixing is. And we're trying to make it more clear here, just to be able to mix and match from both of them. And give actually the data science or the data engineer that's trying to install it, maybe the tools that are specific to their area of interest. So that's it for the releases. I always like to show this picture. It shows the different phases of the operator. Like I said, we are Go-based operator, but we are in only phase 1 today, basic install. There's many different phases down the line. They're very interesting. I think our next step would be to get to at least seamless upgrade with phase 2, and we're looking forward to other phases down the line. So a little bit about Kubeflow. So Kubeflow is a very popular AI/ML and platform that runs on Kubernetes. And it's mostly, I would say, targeting the machine learning part, which is creating the model, the parameter tuning, etc., and so serving the model. I'd say it has tools for model training like TensorFlow, PyTorch. You could do model serving for Seldon, using Seldon KF serving. Pipelines are a big thing too, and they have a portal, and they are UI driven, which is very good. And then anything you need to know about Kubeflow is kubeflow.org, and you'll see that part of the effort that we did after we actually brought Kubeflow and made it run on OpenShift, we contributed to the community, and you see on the menu here on the left, if you go to kubeflow.org, you'll see that Kubeflow and OpenShift is also there with instructions on how to install and download it on OpenShift. So a little here, I kind of try to drill down here on the goals and the issue strength, why we did this and what are the issue strengths, because I get a lot of questions saying, what is the difference between Kubeflow, Kubeflow and Kubernetes and Kubeflow and OpenShift? And a lot of times when we take open source projects and we try to run them on OpenShift, we see all these issues, right? So many of the issues that we saw, for example, are backs. Most of the open source projects are always cluster-wide. Everything wants to be cluster-wide. We try to make it more namespace bound, and that's still an ongoing process, so that we give more control for the user who owns the namespace, and so that the cluster-wide DevOps are not worried about cluster-wide permissions. Another issue that we see all the time is default service accounts always used for everything. So a good practice would be to write service accounts for different services and make sure that you have the right permissions for each one, and don't give default every single permission out there. Containers with root privileges, we've seen those a lot, so we try to change those to get rid of root privileges. Restricted user IDs and group IDs. You cannot use any user ID, group IDs in OpenShift. There's a certain range of numbers that you can use, again, for security reasons. Finalizers most of the time are not specified, and that does not work in OpenShift. We also see some file system access issues where they're trying to access a file system that they don't have permissions to do. Docker dependencies, a lot of the tools, for example, I always tell that example, Argo, they assume that Docker is running on your platform, and on OpenShift we have Creo. So a lot of the API calls for Docker won't work. So we try to change that too to make it adaptable to OpenShift. And then some mutating webhooks, I won't talk about that, but that's, like stale mutating webhooks left over after installing, reinstalling, clearing those up. Those are some issues that we see. And then we also had some operator and operating lifecycle manager issues that we saw, and we tried to adapt to the OpenShift way of installing and uninstalling, clearing and cleaning up. A lot of cleanup needs to happen. A lot of the open source project don't really clean up after deleting, and that's one of the issues that we see. So what are the goals really? So the goals is to bring Kubeflow and get it ready to be installed in OpenShift. And I'd like to say is I always put that one-click install from OpenShift Operator Hub. It's more than one click, but but the goal is to get it to one click where you can install Kubeflow and OpenDataHub together integrated. And of course, we want to move more into the UBI-based images and partner certifications, tight integration with OpenDataHub, as I explained, the mixing and matching of components. And it's not just the mixing and matching of components, but it's also integrated in components. And I'll go through one example here in a little bit. Of course, everything we do that we change in Kubeflow, we try to give back to upstream. And not only that, we try to do it in a clean way where we use a lot of overlays, OpenShift overlays, so that when we are integrating our code or when we bring Kubeflow down, we can just add that overlay. And that overlay does not really change code. It just changes, it basically, if you add it, it just changes some of the parameters that are there in the menu. So that's it for the ODH goals and ODH and Kubeflow goals. So a little drill down here on the different tools that we have today when you install either OpenDataHub or Kubeflow, starting with the persona of a data engineer or a business analyst. They have access to storage. Like I said, we're working on including storage within OpenDataHub. There is Minio that's included in Kubeflow installation. So we have SQL interface and we have S3 interface into the different bucket storages or SQL-based databases. Then we have Kafka for streaming. We have for data exploration, Superset for visualization of the data, and Hue also for exploring your data and SQL access. Big data processing, we have Spark and Spark SQL Thrift. Metadata, we have Hive Metastore that comes with OpenDataHub and metadata that comes with Kubeflow. On the data scientist persona, of course, we have interactive notebooks. We have JupyterHub. And I just want to stay here for a little bit in the interactive and show an example of what integration is or how the different tools are integrated together so that we bring this experience to the data scientist. So we have JupyterHub that on the OpenDataHub side that is integrated with the Red Hat OpenShift authentication, and also integrated with GPU resources. So if you do have GPU enabled on your cluster, you will see it in the JupyterHub UI, and you will be able to use it and issue commands on it from the JupyterHub notebooks. And these three integration just shows how we can, instead of data scientists having to figure all that out, we brought it all together in one component, which is JupyterHub. And we want to see more of these integrations moving along. So for distributed model training and tuning, you have Kdub for hyperparameter tuning, TensorFlow jobs, PyTorch jobs, and Spark. For machine learning application, we have a tool called the AI library, and that tool provides you with pre-trained models that you can serve and then just use them instead of training them yourself. And then for pipelines, we have either you can use Argo or you can use Kubeflow pipelines. And Kubeflow pipelines is a bit tricky. We still have some issues with it, which I can explain later, which will also be part of the demo. On production side, we have for monitoring, we have Grafana, Prometheus. One of the main asks or the main requests from our internal OpenDataHub team that's running OpenDataHub internally is to have every single component that we add support a Prometheus endpoint so they can monitoring. They would not accept anything that does not have a Prometheus endpoint. And we do have Grafana dashboards built in. I think we have one for Spark. For model serving, same thing. We have TensorFlow serving, we have Selden, and of course, KF serving from Kubeflow, but we don't have it running yet. And then pipelines, you can either use Argo or Kubeflow pipelines. So this is kind of a deep drill into the different tools that we have. Moving on, this is just contact and engagement with regards to OpenDataHub. The point of entry for all information OpenDataHub is opendatahub.io. We are on GitHub for the new OpenDataHub operator. You'll see several repos there, the manifest, ODH manifest, and the operator repo. We have a community mailing list that you can subscribe to and get our announcements or ask questions. And we also have community meetings that are open to everybody that happen on Monday every 2 weeks. They're bi-weekly. So if you want to add the calendar, please go to that link. And I'll provide the slides here, Diane, at the end so that everybody can copy paste the links. All right, so where is OpenDataHub used? Of course, there's, as I mentioned earlier, it is used internally in OpenDataHub, and we have a couple of customers also that use OpenDataHub in their companies. So internally, OpenDataHub is used for different kind of analysis. There's application log analysis for anomaly detection. We have cluster metric, operational metrics for OpenShift gathered, and also analysis there with regards to AI ops. Customer data, also SOS reports and customer feedback also is used with data analysis there. And we also have a project with, we also have OpenDataHub installed in the Massachusetts Open Cloud, which is used by students of these different universities to do their research work, Harvard, UMass, MIT, etc. And we're working on, I think, maybe upgrading this OpenDataHub there to the latest hardware that they're using. And making sure that data scientists are using it. And that's it, I think, for slides. Now time for the demo, exciting part. So the demo is a basic demo. It is not a complicated demo. It's just a basic demo to show how you can install Kubeflow using OpenDataHub operator. And then the second part would be just to show an example of how you can start, how you can move from a notebook to a pipeline. And at the end, also another example that I have for Kubeflow is Kdip hyperparameter tuning. So let's go here. I have 2 clusters in case one of them crashes, but let's see. So let's say this is the first cluster I have. And if you want to install OpenDataHub, which I already have installed here, but you'll see, you go to Operator Hub. Let's just go to, let's try it here. All right, so you go to Operator Hub and you do Open Data, and you'll see it here. I already installed it, so I won't install it again. But you basically go through the steps, and you'll see a basic install here. I'm not going to install it, and you'll see 0.6.1, and it shows you the different components that you have. These are only OpenDataHub components, and you'll see that there are 2 channels, the beta channel and the legacy channel. And if you want to install Kubeflow, you have to go to this example here, and I'll show you in a little bit. Just raw. So this is the manifest. Let's go through it really quick. So what the operator is doing is handling this kfdef custom resource. And in this custom resource, you basically define all the tools and components that you want to install. In this specific one, this is going to go in a namespace called Kubeflow. So we create that namespace. And it's going to go through all the different Kubeflow components. And you can pick and choose which one you want. If you don't want it, you can just delete it. And each one component is a customized config option with a name and some information. And you'll see the first one is OpenShift. And this OpenShift, it basically has the changes that I described earlier on. So we can take it out, put it in. It doesn't change any code. It just adds or changes some of the code. And then you'll see here you have Istio. It will install Istio, which is the gateway. It's the way the routing that happens with Kubeflow. And then you'll see this one that commented out. We haven't gotten to it yet. I won't go through all of them. Argo, etc. So you have to copy this manifest because that's what we're going to be using. And I'll just go here really quick. This is the Kubeflow project. So you create the Kubeflow, you go to installed operators, you'll see the operator installed, and you create an instance of the API. And then you'll see here that the default instance that we have is actually OpenDataHub. And you'll see these are the OpenDataHub components. We don't want that, so you copy paste the one that I just showed you into this, and you hit create, and that's all you need to install Kubeflow. And I just wanted to point out, here are the two actually GitHub repos where these components are being installed from, and you'll see that for Kubeflow manifest, it's the 0.7 branch, and then for the OpenDataHub manifest, it's basically 0.6.1. So we do this, we install, we create, and then what happens is you'll see here the Kubeflow KF-def that we just created, and you'll see all the pods that are running. So just a quick note here, and I'm going to make it a little bigger because I know most of you cannot see this. So you'll see all the different pods with the different components installed already: Knative, Jupyter Web, Central Dashboard, etc. So now that we have installed Kubeflow on OpenShift, the question is, well, what do I do, right? How do I get to that portal? To get to that portal, you have to go to Istio, and then you have to go to networking and routes. And you'll see here the Istio English Gateway, and you hit on the link here. It will bring you to the Kubeflow main page. So the Kubeflow main page that you'll see, because here I already logged in from before, but this is basically the main page, and you will be asked to enter a name before you actually go into this main page. Please enter something meaningful. I entered Nakfour. That would be my namespace. If you'll see here, the drop-down menu will have Nakfour, my namespace. Some of the stuff will run in my namespace, some will not run in my namespace. For example, the notebook servers will run in my namespace, and I'll show you now, while pipelines still run in Kubeflow. They're not there yet, and I think maybe in Kubeflow 1.1 they will be. So this is the main page, and for the first example that I'm going to show you is the notebook servers. So if we click on the notebook server, make sure you select your Nakfour or your namespace that you created, or the profile that you created, because that's where you want your notebooks to run. So I already created one here before. Let me see if I can show you. No, let's just do new server. You basically give it a name. Let's call it open. We can call it. So the name doesn't matter. In this specific demo, we want to use a special image that has Kale. Kale is a new tool that one of the Kubeflow teams are working on, and I'll show you how it works. But basically, you want to put in a custom image that has a Jupyter lab that has Kale already integrated. Right. I'll make this a little bigger again so everybody can see it. You leave everything almost the same, but you do want to add a volume to it, and it could be by default. And then you just launch this. All right, so when you do this, what happens is if you go to your namespace that you just created, you'll see the pods running there trying to create that server. So this one's pre-created and it's running. So we're going to after it's being created, we're going to connect to it. So I'm going to go and do the older one, which is I had before, hit connect, and it's going to bring me to this. Actually, it's going to bring you to this. So this is the main Jupyter Lab portal. And what I did here is I have a little example for predicting a house price. And what it's doing is a little notebook example. That's really, really simple. I took it from here, GitHub. There was a very good tutorial on how to get data, create a deep learning model to predict whether a house price is above or below market average. And the data included things like, how many bedrooms there is, how many bathrooms, etc. about the house. And these are the features. And the input was whether yes or no, this house price is above or below. So basically the first step, and I'm going to do something here really quick. This is okay. I'm going to turn it off for 1 second here. And then I'm going to run these. So this is just, the first one is just important. libraries didn't do much. This step, what it does is grabs the data sets, divides it into X, Y. X is your features, Y is your input. It's what you're trying to predict. And then, of course, divides it further on into training, evaluating, and testing. So we'll run this. I'm not going to go deep into what's happening here. It's really, really very simple, and it's probably not the way to do it. But just an example, it's fine. And then here we're building a neural network. It's a sequential Keras deep learning network. It has 3 layers, and then we specify the activation algorithm that we want to use. And then we also specify the optimizer, the loss, and the metrics, which is accuracy. And then we do the model fit, which is actually training the model. And then we do the evaluation. So we'll run this here really quick. And you'll see it goes through all the epochs. And in the end, it's going to spit out a number, which is 0.9. I think it's good. This is actually just evaluating the model. So this is our notebook. Now, the use case here is that the data scientist has created this notebook, and now they want to turn it into a pipeline. And that pipeline would be, for example, run maybe on a daily basis, or when new data comes in, or any triggers that they want. So with Kale here, all you have to do is turn it on. You'll see this is kind of an extension to the Jupyter Lab. You give it a name, and then you go through. I did it before, that's why you see it. But what you do here is you hit the edit button, and you say what cell type do you want. In this case, it's imports, meaning it's going to be on every cell. And then you'll see here, this is called prep data, and it's a pipeline step. And then the third one, which is pretty interesting, it's a pipeline step called train model, but it depends on prep data. And you'll see how that will show up on the pipeline. So I have all this set up here, and I want to change it into a pipeline. So what I'm going to do here is compile and upload. There's other options. You can compile and run. We're not going to do that because it's not going to run right away. So we're going to do compile and upload. And you see that it says the pipeline was successfully uploaded. Now we're going to go back to the main Kubeflow page, go to pipelines. And you'll see here W301, that's the pipeline that was generated. And if we look at it, you'll see that we have the prep data that we had before, and we have the train model. We never had that, but that's okay. That's part of the generation of this pipeline. It creates volumes and uses that volume to move data between the different steps. So if we run this today, and I wanted to show you some of the issues that we face. If we run this today on OpenShift, this will not work. Because in OpenShift, as I explained earlier, this is using Argo that is assuming we have Docker, but we have Creo. So we have to change the pipeline to not use file system, but to use volumes. And then I also had some of the containers that are running here need root access, so don't do it. But I did make some changes to actually allow it to run root. But we'll fix this. This is all fixable, not a problem. But just to show you here, so I did upload the actual pipeline that is fixed, and you see I got rid of the last one, the first one, because cannot use it the way it is. And then we can just hit create a run, and we run an experiment, call it test, very innovative name, and start. And you can see I ran it multiple times, make sure that it's running. But what it's doing here, let me just go back to the pipeline. As I explained, does not run in your namespace. You'll see nothing here, but it's actually running in the Kubeflow namespace. And we should see all the different house prediction pods. And they might have been done. Yep, this first one is done. And if you see the logs here, those are the logs from the actual that we had in the notebook. And I wanted to show you one thing actually. Here, let it run, and it's the train model, and you see all the epochs running. I wanted to show you, let's go back so to pipelines, show you actually, let's look at this. The actual code that we had from the notebook is embedded here in the container. It's basically right here. So this is all the code from, I don't know if you see it, but this is all the code that's coming from the notebook. And every step you'll see it's the same thing. So that's it for the Kale demo. I think this tool has a lot of potential. It needs still a lot of work. I don't think you can define if conditions or for loops in the component, but I like the way that it is user driven and very easy and intuitive for data scientists to use. All right, so my next example or my next little tutorial or little demo here is with Ktip. And Ktip runs in your namespace. Sorry, my internet today is really slow and the UI shows it. So what I'm going to do here is run a little experiment, a hyperparameter tuning experiment. Let me just make this a little bigger. Right, so we are going to create an experiment that runs TensorFlow jobs and tunes these parameters that I'll show you here in a little bit. So as you see, and hopefully you can see this big enough, it runs in my namespace. That's the name of the actual experiment. It's going to run TensorFlow jobs, and the goal is to maximize accuracy. And the parameters that we're going to be toggling in these experiments is the learning rate and the batch size, and you'll see them here. And we're giving it minimum maximum, so that's what we're toggling in this experiment. And that was just one of the examples that they had in Kubeflow. It's just off the shelf. I didn't really write this. I just grabbed it and made it run. And then the container that we're running is just an MNIST TensorFlow model that can not predict, but actually show you numbers, show the numbers. All right, so this is what it's going to do. I'll show you here, but I just want to hop really quick. Sorry for hopping, to show you the actual code for this MNIST model, just kind of quickly. So this is the actual code that's running in the container. I'll make it a little bigger here, hopefully. But basically, what I just wanted to show you is that it has API to toggle these numbers. I think my machine is stalling. To toggle these numbers so that when the experiment is running, it can call this API so that it can get the accuracy back from changing these settings. All right, let's go back and run it. Okay. And again, I don't think data science would like to use command line, but this is how I think you can also do it from the UI. From the UI, you can also create something there from the UI. So let's get experiments and take a look at that. And you'll see I have one that I created before, one that succeeded, and one that's running right now. And if we do look at the TensorFlow jobs, all right, you'll see that 3 of them are running in parallel and they are getting the parameters. And I will show you on the UI something that I ran before and how the results are going to show up. So if we go to Ktip and we go to hyperparameter tuning and monitor, you'll see that there are 2 jobs, one that ran before and one that's running. It takes a while. So let's just look at the one that's running, and you'll see the different parameter that it used. So you'll see for accuracy 1, the learning rate that was used is 0.014, and then the batch size was 101. So this is really simple, but you can do a lot of complicated things with this, with tuning parameters, changing parameters, and seeing which worked better. And you can see here all the TF jobs that ran, and then they succeeded. I think that is it for the presentation and the demo today. Let me see if there's any questions.
There's one, Juana, and it was more to do with the CD workflows and whether or not it was possible to put Flux in to replace Argo.
Oh, for the pipelines.
Yeah.
So from an OpenDataHub perspective, we have actually Airflow. I probably did not mention it, which I should. So we have Airflow for pipelines and we have Argo for pipelines. From an OpenDataHub perspective, yes, we can replace this with pretty much anything that has a manifest and is a pipeline and that works over OpenShift. From a Kubeflow perspective, changing actually Kubeflow pipelines to work with a different pipeline provider other than Argo is probably a more complicated process because there's a lot of dependencies. And they write pipelines in Python and they have to compile, they have an SDK to compile the Python to YAML. So it's not straightforward. I don't know if that answers the question.
Yes. I think it does
Yeah.
to a certain point. If Waleed, if you have a follow-up, let me know. The other question that I have, and it sounds like it might be a similar thing, is this Docker versus using Cryo or Podman or the other bits? Is there work going on in the Kubeflow community about making it more compatible with the Cryo, the OCI stuff? Is that coming down the pipe?
So there's two levels of this. There's the Argo level. They have provided executors that work with other, not just don't have a Docker dependency, but there's still some issues with it that needs to be. It works, with like this, but they need to fix some stuff to make it easier.
Never good.
Yeah, and then there's also the Kubeflow part where I think they populated a way where you can specify. I don't have Docker, I want to use a different executor for Kubeflow, but they still have things that they use in their pipeline that use, for example, file system instead of using volumes. So that part, if they can, for example, if you specify something other than Docker, use volumes for everything to move parameters, to move artifacts around.
Yeah. So is that something we can contribute back to the Kubeflow community, or are they stuck on just file systems for good reasons? Do we know the answer to that?
Yeah, of course we can contribute. I think it's more of a manpower issue. The more people we have helping, right, the more we can contribute that. But we are, it is in our plan to have Kubeflow pipelines working the way we want it on OpenShift. So it just needs a little help, and hopefully we'll get it in the near future. And we're also waiting on Argo. I think they have fixed some issues. So we're also waiting on them. Hopefully, if you do specify something other than Docker, then your volumes are good to go. So we'll see.
I've always been kind of interested in, it's sort of like the interdependencies of all these different projects.
Yeah.
When you need a feature in one, how do you get it into the next one, and how do you be aware of all the different things? And that's like the bane of our existence in community development and trying to manage all of these timelines. And I noticed that Kubeflow is still at 0.7 or
it's actually 1.0 and 1.1 is about to be released.
Okay, good. So it did make it. The last time I looked into it, it was like 0.7 or some early thing. And I was thinking, geez, they must have gotten to 1.0 by now. So.
Yeah, it's 1.0, but not all components are 1.0. So Kubeflow pipelines, I think, wasn't in 1.0, but it's going to be in 1.1. So it got a little complicated.
Yeah. So someone is asking in here whether or not where is this operator in OperatorHub.io? And OperatorHub.io, if you don't know, is the community side of things, and it works with all the generic, anyone who has a generic open source or wants to put their operator in there that works with generic Kubernetes goes there. And as Juana has been explaining, we're still not getting OpenDataHub yet to be generic for all of these other myriad of reasons and domino effects of things rippling through different projects. So we're working on it. We're getting there. And
yeah, so I do get this question a lot because I think OperatorHub on OpenShift is pretty confusing to OperatorHub.io, and they're totally different. I don't know why the names are the same, but they're different, yeah.
Oh, I'll tell you because I named it. I'll tell you who the we is. You can blame me for that. The OperatorHub.io is really just a catalog with a UI, HTML UI on it that was, as we were beginning to build out the operator pattern and the operator framework and all the tools, a way to bring people and help people understand what operators were and how to use the SDKs and OLM and all of that good stuff. And then and I blame this confusion on Red Hat marketing, because then they called the same thing inside of OpenShift that
electrical tape on it now, so it's not on my desk because you could hear the pounding of my hand on the desk.
I named mine first.
I couldn't do that, so I got it kind of rigged up right now.
But it brings up the thing is, if you wanted to stand up your own operator hub, a private one or something that was specific to a certain topic area, maybe ML, AI, you could do that really easily. And all the code for Operator Hub IO is in the open source repo.
Yeah.
Which brings me to another topic, the operator framework. So if you're building an operator, like the OpenDataHub one, if you go to operatorframework.io, all of the tooling is there, and all the explanations there are for building out operators and all of the bits and pieces you need to learn about how to do that and get it certified if you want it into the OpenShift Operator Hub or Marketplace. So there is a lot of confusion.
Yeah.
We keep trying to clean things up. But yeah, marketing, I love them. And
yeah, not much user experience put into this, like user experience thought.
Yeah. So what I'd like to see is, and this is getting off on a tangent, is more automation behind Operator Hub IO, so that the onboarding process was simpler and faster.
Yeah.
There's still, even with the certified stuff, there's still some hand holding and the testing suites and all that good stuff.
Absolutely, yes.
But that said, you guys have done a great job getting the Operator Hub data operator into the OpenShift operator and making it work easily. So as seen in the demo.
I don't know about easily. Yeah, the one-click thing, right? Yeah.
And that's the whole thing about operators, is they are supposed to simplify and get to that one-click. I call it the one-click fantasy experience. I think everybody who's ever said anything about any piece of software is, I want to install it in one click.
Yeah, 99% of them.
Yeah, that's what the folks say. They want that iPhone experience, and I think that the interesting thing is we can install it, but there's so much in Operator Hub that you have to know a little bit about Jupyter notebooks, or what a pipeline is, and all of these things. And I think what Operator Hub has done nicely is create a unified experience for all of that.
Yeah.
And because I have been working on a couple of COVID projects up here in the north. I'm way up north above the 49th parallel in Canada, about in my own little bubble. And the folks at howsmyflattening.ca are working with Guillaume Moutier, and who came to Red Hat out of Laval University, where they were doing a lot of ML stuff. And so I think they've been working to move some of the work that they're doing into, I think maybe a POC as well with OpenDataHub. And so we had them on a couple of weeks ago, and we were talking about it as well. The other thing we're going to do, if you're listening anywhere in the Twitch, Facebook, YouTube live streams, is on July 20th, we're going to have members of the OpenDataHub team, some of the engineers and the data scientists that have been working on it, do an AMA session. And hopefully maybe we can squeeze Juana into that as well, and bring some of the Kubeflow community people in there, and just basically answer anybody's questions about this stuff, and talk a little bit more about maybe the coordination of some of these pieces and parts, because I think that's my personal goal is not one-click install. Mine is one-click install on anything, whether it's OpenShift's Kubernetes or OKD4 or anybody's version or DIY Kubernetes, just so that this pretty wonderful project gets a lot more feedback, a lot more community members joining in and using it. So mass open cloud has been.
That doesn't work on mobile today, so
no, not on mobile.
Your goals are pretty up high.
I know. I live in a fantasy life, so where everything is one click. So So I know there's a few other people from the team on here, Beverly and Peter and stuff, and a few others. I'm sure I don't know all the names of the team members. So if there's anything else that we missed and didn't cover off here today, feel free to pipe in. If you can pop over to the share your screen just for a second and just pop over to the OpenDataHub page, not for the beautiful UI. Share your screen again and pop over there, just so people know where all that is. And
you mean this one?
Yeah, the OpenDataHub.io page.
Oh, the actual OpenDataHub.io.
The actual OpenDataHub page, because there's actually quite a lot of content on there as well, and it makes it really easy to get started. And the docs, I think, for a project are just pretty damn awesome. So if you're really interested in doing this, everything she talked about today, the Airflow, the Kafka, the Spark, Superset, Argo, and Grafana, all of that, along with this AI library that they've been working on, is available there too. And it's, I know it's got a lot of red hat labels on this stuff too, but there's a lot of great content here, and a lot of people, a lot of other open source projects have gone into making this a reality.
So yeah, we have tutorials and a lot of information about the actual components that are there. We also have a lot of blogs on developer.redhat. So if you just go to developer.redhat and search Kubeflow or search OpenDataHub, you'll see a lot of blogs on how to do things and information about our releases. And then, of course, here the community part is how to join our community meetings, adding the Google Calendar where the source code is and where the mailing lists. And then the news is where all our publishing is. So when we have a new release, we release notes, we publish them here, or any other blogs, we publish them here. So that's it in a nutshell.
All right. Well, then I can see that I need to send a note so we get the AMA session on your news flashes. So I'll definitely do that shortly and send you guys the link, and we'll get that going. So I don't see any more questions in the chats from any of the different things. So we do have a lot of people watching. So you're being quiet, which means you did a great job.
No, it means they didn't get it.
Well, no, I don't know. Now they got to go off and play with it. So and test it out. So I was having a conversation yesterday with Carol Willing, who's now with a new company, .io or something like that. I forget what the name of the new company is, but she's the force behind Jupyter Hub. And I'm going to try and get her on again sometime soon. She was on a little while ago. So
so just to reiterate to everybody, OpenDataHub is an open source project, and everybody's welcome to contribute and join us in the project. You can start by attending our meetings or submitting PRs or reviewing PRs. You're all welcome.
All right. Perfect. That's a perfect way to end on it. So thank you very much, Juana. And we'll make this happen again on July 20th and force people. Maybe we'll have to give away swag to get questions and get them to be a little more talkative. So thanks again for taking the time.
All right. Thank you very much.
All right.
All
Bye.
Right. Bye.
Recording has stopped.
So Waleed, you had a question, but yeah, go ahead.